All right, good morning, everybody. I guess a quick announcement. The last assignment for the course will come out later today, maybe tomorrow. It'll be due on the Monday before the exam period. But you still get the 3 days you still get the 3-day universal accommodation. I guess next week I'll post information about the exam. The exam is all C, so there's no bash on the exam. It's not a comprehensive exam, and it's only 2 hours long. So it's not a big 3-hour exam. Now, you probably have noticed, I imagine you get some sort of information about where the exams are. I guess there are 230 students in this course, and so they've split us up over 3 rooms for the exam. One of the rooms is not close to the other 2, which is unfortunate. So it's not clear if I'm going to be able to be at the exam to answer questions, but I will try. But it just means I'm going to be walking around between buildings across campus, which kind of is inconvenient. All right, so remember at the beginning of last class, I showed you how to use our generic stack, right? Remember in our generic stack, when you push elements onto the stack, you're not actually pushing elements, you're pushing pointers to elements. And so you have to be careful to make sure that the things being pointed at actually exist, right? And so the original version of this function f, right, would push the address of y onto this stack, right? And we saw that when you ran the program that, you can't see that? Sorry. Okay, so our original function f, we'd push the address of y onto the stack. Right now, notice here y has automatic storage, so it no longer exists after the function. In principle, it no longer exists after the function finishes running, so you can't actually use, so a pointer to y technically will produce, or trying to use a pointer to y after the function returns technically reproduces undefined behavior. Ooh. Right, and we did in fact see that if you ran the program, we didn't get correct values pushed onto the stack. Right? After we fixed that, so the answer is you have to make sure that the objects that you're pointing at have allocated storage, or I guess static storage duration would work. Right? So we fixed it, everything seemed to work, right? And then I showed you that if you free the stack, because you're allocating the elements here, you have to deallocate them at some point, right? And our stack, the implementation's nice because it has a function that will free the stack and free the elements if you ask it to, right? And so you can just call stack free at the end. But then when you run the program, you get an error, which was embarrassing. But that sort of thing happens when you try to do stuff on the fly, right? So it turns out there's actually not an error in the stack implementation, right? Notice here you have a free invalid pointer, and the program aborts, right? So the program does not end cleanly here. Right? There is an error in the program. It's not in the stack, right? And it's because it's in the main function, right? What did we do here, right? Well, we did exactly what I told you not to do, right? So we made a local variable I that has automatic storage, right? And then we passed a pointer to I to push onto the stack. Now that's fine until you try to free that element. Right? You can't free an object that wasn't dynamically allocated, right? And here I was not dynamically allocated, so that's why you get the invalid pointer error here, right? That thing there, it's trying to free whatever I is pointing at, and you're not allowed to do that. I has automatic storage. You can't free that memory, right? It's not allocated storage. So the problem wasn't in the stack code itself. The stack code's fine, as far as I can determine, right? The problem is the demonstration program here, right? You really have to be careful. If you do this sort of thing, right, then when you free the stack, you don't want to free the element, in this case I, right? So when you call stack free here, you should pass in null to tell the stack free function, don't deallocate the elements, right? If you're pushing elements onto the stack from a function, you have to make sure that those elements have allocated storage, right? In that case, then you want to tell the stack to free those elements, right? If you have a mixed, if you're doing mixed pushes of elements, so here we're pushing one that has automatic storage Here we've got one that has, sorry. Here we're pushing one that has allocated storage. Here we're pushing one that has dynamic storage. Wait. Here we're pushing one that has automatic storage. Here we're pushing one that has allocated storage. Too many A's, sorry. Right? You're stuck here. Right? There's no safe way to have the stack free the elements. Right? Now the programmer, so me, I have to know which elements can be freed manually and which ones cannot. Right? So that explains the error that showed up in the last lecture. Right? So we can fix this. Right? So here we can do the same thing. So we can create an allocated storage pointer. Right? So new malloc size of int. Right? So now I've got a chunk of, oh wait, new malloc, malloc, right? So now you've got a chunk of memory that can hold an int, right? So I now have an allocated int object, right? I can set the value of that object to be equal to I, if I can type, right? And now if you compile this program and run it, everything, oh, what did I do? Oh, I'm still pushing I, sorry. Right? So now I can push a pointer to the allocated element, recompile the program, and now everything runs just fine. Right? And so that explains the error that we ran into last time. Right? Notice this little example illustrates the problems with memory management in C. Right? It's not easy to do, even in a tiny little program like this. Right? It's the source of many programming and security errors in C programs. It's also one of the main motivations for the creation of the Java language, right? And I guess subsequently Python. All right, so we were talking about strings at the end of the last class. So we do the string length function, right? That's the function that returns the length of a string. Down here, I didn't mention it, but there is another version of string length. Right? So there's string n length underscore s, right? This is a standard library function, so it does exist in string.h, right? This is what's quote unquote the safer version of this function, right? So what you'll see in a lot of the standard library functions, especially the ones that work with strings, is that there's a version of a function that looks like this, so string length. There'll be another version of the function that's got an n somewhere in it, right? And so whenever you see what seems to be an unnecessary n somewhere in the function, right, that corresponds to a function that, or a variation of the function that takes in an extra parameter that tells the function, that specifies the maximum number of things to do before the function stops, right? So here's string n length. That version of the function will try to give you the length of the string up to a maximum length of n. Right? Now, why does it have to do this? Right? So remember, in C, all strings are just null-terminated arrays. So the way string length works is it just looks at the characters of the array until it sees a null terminator. If the string's not null terminated, string length in principle runs forever, right? Or it runs until something bad happens, or until it finds a value that's all zero. The n version of the functions, typically you specify some extra parameter, right? And this function will stop if it hits the value n, right? And so this one potentially prevents the problem of falling off the end of the array, right? It doesn't guarantee it because there's no guarantee that the value of n that's passed into the function is actually the size of the array or bigger. Right? But these variations of the functions do exist. Right? So there is string copy. We saw string copy, right? Yeah, we saw string copy. Right? So just like strn length, there's an strn copy. Right? The quote unquote safe version of copy, of the string copy. Right? So strn copy has this extra parameter here called count. Right? So that will copy at most count characters from the source array into the destination array. Right? Notice there's a bunch of undefined behaviors in this function. Right? So if that array If the length of that array is less than count, right, then you've got a problem, right? Because it's string n str n copy is still going to go past the end of the array, src, right? So even though these are called the safe versions of the function, there's nothing safe about them, right? There's no guarantee that count is less than the length of the array. Sorry, I just want to go back to string copy. Okay. So this function here is useful if you want to copy, well, it's potentially useful if you want to copy part of a string into another string, right? Because it has this parameter count, right? So it'll copy at most that many characters from src, right? So if you want to copy part of src into destination, right, then this is a function that you could consider using, right? So for example, here I've got the string consisting of the digits 0 through 9. So there's 10 characters in that string, right? There is an array of length 10, right? So I can copy a string of at most length 9 into that array because I need the null terminator, right? So if I want to copy part of S, so the 3, 4, the 5, into T, you can do that with this function, right? So I'd like to copy the 3, 4, 5. So I need a pointer to the 3, right? So the pointer to the 3 is just S plus 3 in this case, right? S is a pointer to the 0. S plus 3 is a pointer to 1, 2, 3. So it's a pointer to the 3 in this case, right? If you want to, you can write S square bracket 3 and put the ampersand in front. I want to copy 3 digits, right? So I want to copy the 3, 4, the 5. So the count is 3. Right? Where do I want to copy them to? I want to copy them into the start of T. So I can pass in T as the pointer there. Right? Now, strncopy will not write the null terminator if the part of the string you're copying doesn't contain the null terminator. Right? So you have to remember, you have to insert the null terminator here. Right? Anytime you've got to do something like that, that's a big problem. Right? Programmer needs to remember they have to insert the null terminator. It's very easy to forget to do that. Right? If you forget to do that, there's no guarantee that T has a null terminator anywhere in that array. So any function that now gets T as a string can possibly run past the end of the array. Right? So that's a very dangerous side effect of this function. Right? And not surprisingly, this function gets a lot of criticism on the internet, right? Because it doesn't guarantee that the string that it's copying into is null terminated. There's a whole bunch of other functions you could consider using, right? So there's an strncpy underscore s, right? There's an snprintf, there's an snprintf underscore s, there's strlcopy, which is not a standard library function, right? We're not going to go through all of these because they all, I mean, you just look up the documentation for how to use them, right? They all have their, safety issues associated with them. Right? They try to be safer than strcopy, but they have their own problems as well. Okay, so string concatenation. Python and Java, you just write plus, right? You can concatenate anything to the end of a string in both languages, right? In C, it's not so easy, right? So for example, if you wanted to copy or concatenate an integer onto the end of a string, we don't know how to do that yet, right? So we'll see how to do that later on. If you have 2 strings, though, you can join them using strcat, right? So source string, destination string, right? Takes the source string, adds it to the end of the destination string, and tries to null terminate the destination string. Right? So both strings have to be null terminated, right? The pointer that's returned is just dest, right? So you get a pointer to the string that was just concatenated to, right? Like all the other string functions, there's a whole host of problems that you have to be on the watch out for, right? So you're going to join that to the end of that. So there has to be enough room in the destination array to hold the concatenated string. That's a big security problem, right? It's very easy to create a destination array that's too small, right? When you join source to the end of dest, you now run past the end of the destination buffer. This particular version of the function, the strings are not allowed to overlap, so you cannot concatenate a string to itself with this function. which is inconvenient. Right? But if either of these is not null terminated, there's a potential problem, right? All of the string library functions assume null terminated strings. You can kind of imagine how this function is going to work, right? It's going to iterate over the characters of src until it sees the null terminator, right? In every loop iteration, it's going to take the character from src and stick it onto the end of destination, right? All right, so this is going to be my destination array, right? It contains 5 characters in it, plus the null terminator, so it has 6 things in it. Right? There's t, right? T has another 5 characters in it, right? I would like to append, sorry, which one's the destination? S is the destination. I'd like to append the 5, 6, 7, 8, 9 to the end of this array, S, right? So I'd like to get the string 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? How do you do it? Well, I can just call string cat, right? So concatenate t onto the end of S, right? If you make 11 smaller, right? So if you make it 10, right? There's no room for the null terminator, right? So string cat is going to run off the end of t, off the end of S, sorry, when it writes the null terminator into S, right? That may or may not cause problems. If you make that small enough, you will eventually run into a problem with string cat, right? But otherwise, this works. Right? Not surprisingly, there's also an strncat. Wait, where to go? Where's the slide for it? There's no slide for it. Right? There is a quote-unquote safe version of strcat. Right? It's not safe. So strncat takes in an extra parameter. Right? The extra parameter is called count. Right? And so strncat will append at most count characters to the end of the destination string. Right? Seems sensible. Right? Seems like a sensible function to provide people. But the problem is that programmers misinterpret count to mean the total size of the destination string, right? So rather than appending 5 characters to the end of a string, right, it's very easy to think that count means what is the length of the final string, right? Which is a big problem because if you say 5 is the length of the final string, but really it's appending 5 characters into the string, right, then your actual final string is a lot longer than you think it's going to be. Right? So, for example, right, here's 0, 1, 2, 3, 4. Right? There's my string 5, 6, 7, 8, 9, 0, 1, 2, 3, 4. Right? I would like to append the 5, 6, 7, 8, 9 onto the end of S, right? And so if you pass in 10, mistakenly thinking that that's going to be the final length of S, that's going to be a problem, right? What strncat does is it takes 10 characters from T, sticks that onto the end of S, and now you've got a problem because S can't hold a string of that length, right? So even though you're using the quote-unquote safe version of the function, it's not safe at all, right? There is no actual way to make a safe version of these functions. Right? Because C strings are null terminated, right? And, sorry, because in C, the array length of an array is not kept, right? So there's actually no way to make a safe version of these functions because you can always write past the end of the array, and there's nothing in the language preventing you from doing so, right? And there is no mechanism in the language that lets you do so, right? So contrast that to Python or Java, right? So in Java, if you have an array, the array knows how long it is. Right? You just ask for the length of the array, right? In Python, you have a list object, so it also knows how long it is, right? In C, arrays don't know how long they are, right? Which I guess in retrospect seems like a really big design flaw, but you have to remember the language is very old now, right? Okay, if you want to compare 2 strings, again, you have to remember strings are just arrays. So you can't compare 2 arrays for equality or inequality in C, right? Equals equals and not equals, that doesn't work, right, for arrays, right? They work for pointers, but for pointers they mean, are the pointers pointing at the same object, right? If you have 2 strings, they might have the same sequence of characters, right? And if you use equals equals, it's always going to return false if the two strings are actually distinct objects, right? Because they're not, because again, remember, equals equals says, do the two pointers point at the same object, right? So you need a function instead. So that function is strcmp. Right? This works like compare to in Java, right? So the string, the compare to version for the compare to method for strings in Java tests whether or not two strings tests two strings for order, right? Is the first string less than the second string? Is it equal to the second string, or is it greater than the second string? Right? Less than and greater than are lexicographical order, right? So if S and T are equal, you get back 0. Right? If S and T are not equal, so they contain different sequences of characters, you get back a signed integer value. Do I tell you what they are? Yes. Right? So the signed integer value, that encodes the lexicographical ordering of the two strings. Right? So left-hand side, right-hand side. Right? So if you get back negative from strcomp, then the first string comes before the second string in dictionary order. Right? So aardvark comes before zebra, so you'll get back a negative number here. Right? If you get back a positive number, that means the first string comes after the second string in lexicographical order. Right? So zebra, aardvark, zebra comes after aardvark. Right? Again, no safety here whatsoever. Right? We assume that the language assumes that these are both null terminated strings. If they're not, anything can happen. This is just a little program that a little program that takes in two strings on the command line and then tests them for order. Right? So first string, that's just the first string in this array. Right? So that's argv1. Sorry, that's the second string in this array. Right? Remember in C, the main method is funny. Right? Argcount is the number of command line arguments plus 1. Right? Argv is an array of the command line arguments plus one extra thing. Right? The extra thing is the name of the program, which lives in argv0. So your first command line argument is in argv1. It's always a string. Right? Your second command line argument is argv2. It's always a string. Right? So you've got your pointers to your two strings. You can just call string comp on them, right? And then look at the result. Nope. Okay. So the next deck of slides is more strings, and hopefully we'll get to doing some input and output in this lecture as well. Okay, what else do you want to do with strings? Well, it's often useful to search a string for a character, right? So strchr searches the string str for the first occurrence of ch, right? So this is like index of in Java. Right? Sorry, it's like index of plus giving you back the character. Right? So strchr finds the first occurrence of a character ch in a null terminated string str. Right? How does this work? It's just going to search the string, right, character by character, until it finds a character that's equal to ch, or until it hits the null terminator. Right? It returns a pointer to the character. Right? So that's a little bit different than the way it works in Java. Right? Java, you get an index. Right? Here, you get a pointer to the character. Right? If the character is not in the string, you get back null. So that kind of makes sense. Right? That looks a little weird. Right? This character is specified as an int, not char. Right? And that's because of historical reasons. Right? So way back in the early days of C, I don't think there was a char type. There was only an int type. So ints were all encoded, characters were all encoded as ints. Right? And so occasionally you'll see this sort of thing where a character is represented as an int instead of a char, right? This is strictly historical. Yeah. Yeah, you can pass in a char. So char is narrower than int, so the conversion happens safely. Yeah. If you want to find the last occurrence of a character, it's strrchr, right? Also, again, notice that a lot of the C functions, they only differ by one another by one character, which is also problematic, right? It's very easy to confuse this function with that function, right? It only differs in the R, right? The R means it's searching from the end, right? So reverse. So this finds the last occurrence of CH in that string, right? Returns a pointer to that occurrence, right? Again, the character is specified as an int for historical reasons. Right? Now, if you want the index of that last character, right, you have to remember that of the found character, right? You have to remember that you're getting back a pointer. You can get the index because you can just do pointer subtraction. Right? So here we're going to search a string on the command line, right, for a character that's also specified on the command line. Right? Okay, so the string is in the first command line argument, so that's argv1. Now the character is in the second command line argument, but the second command line argument is also a string. Right? So argv2 is actually an array of car, right? So it's a string, right? I only want the first character from that string because I'm searching for a car, right? So I'm going to look at the first character, right, of the second command line argument, right? So that's how you get the character. That's how you get the character from the second command line argument, right? If you just wrote argv2, that's a string or a pointer to a string. Right? So I'm going to use strchr to get the first occurrence of the character C in the string. Right? I'm going to use strchr to get the last occurrence of the string of the C in the string. Right? If you want the index of either, right, you just take the pointer that's returned, so first, right, and subtract the pointer to the first character in the string. Right? So remember how pointer subtraction works. Right, so if that's my array str, right, then str is just a pointer to the first character in the string, right? So if I get another pointer in the string somewhere first, right, the index of that is just the difference of first minus string. Right, so it's just the number of elements between here and here. Right, so that's how pointer subtraction works for arrays. Okay, and finally, can you search a string for a substring? The answer is yes, right? It's just string, str. Right, so that searches that string for the first occurrence of that substring. Right, and like strchr, it returns a pointer to the first character of the substring. To the start of the substring in str. Oh, it's not the final one. There's another one. strtok. So this is a weird function. So strtok is the string tokenizing function that comes as part of the standard library. It's not super useful, and it's also very unusual. All right, so this one requires a fair bit of explanation. So strtok will take a string and it'll split it up into what are called tokens. Right? So if you often you'll have a string that contains some formatted information. Right? So for example, if I download your grades in OnQ, right, I get back a spreadsheet that contains some information. Right? So it'll have your student number, comma, last name, comma, first name, comma, et cetera, et cetera, et cetera. Right? So you get back a comma separated values file. Right? So each string in that file is just the information for one student. Right? So you can split up the individual pieces of information just by looking for the commas in that string. Right? And so that's what this function is meant for. Right? It takes a character delimited string and splits it up into the individual tokens. It does it in a very strange way. Right? If you've ever used split, the string split method in Java, the string split method is a lot more convenient to use than this thing. Right? So we're going to pass in a string, and then we're going to pass in an array of delimiter characters. Right? And so you're going to pass in a string that contains the characters where you want to split the string on. right? So if you had a comma separated string, you just pass in the string that contains a comma, right? Any character that's in this string will be considered to be a delimiter, right? All right, so this one's a bit funny. So this one doesn't return back an array of all the tokens. It returns back a pointer to the next token that it finds in the string, which is strange, right? So it returns a pointer to the next token, or it returns a null pointer if it does not find the next token, right? So in other words, if it doesn't find if it does not find a delimiter character somewhere in your string. All right, now notice these two things here, right? Okay, so if str, so if that string that you pass in is not null, right, then the function assumes this is the first time. Sorry, there's an extra k in a lot of these slides. I have to remember to fix this. Okay, so the way this function works is bizarre. So you call the function, you pass in a string and your list of delimiter characters, right? If you actually pass in a string, then the function thinks this is the first time you're calling the function. Okay? If you pass in null, right, then the function assumes you've called it already before. It's going to try to find the next token, right? So the first time you want to search a string, you pass in the string. Every time you want to extract another token, you pass in null. Right? This is bizarre, right? But this is the way it works. All right, so the first time you call the function, you pass in a string, right? Then what the function does, right, it searches for the first character that's not a delimiter, right? If it finds one, right, so if it does find a delimiter character, it searches for the first character, searches for the first character that is not a delimiter, right? If it finds one, then it searches for the first character that is a delimiter, right? So here's an example. This one I'm going to split at the colons, right? So here there's 4 fields, or 4 tokens, right? Token 1, token 2, token 3, token 4, right? You are allowed to have repeated delimiters are considered to be one delimiter, right? So the first time we call the function with this string, it's going to look for the first character that's not a delimiter, right? So it's going to searches for the first character that is not a delimiter, right? So colon's a delimiter, second colon's a delimiter, third colon's a delimiter. Now it finds the F, not a delimiter, right? Okay, so we found a character that's not a delimiter. So now it's going to search for the first character that is a delimiter after where it stopped, right? So we're at the F now, right? So this function only goes forward through the string. It never goes backwards, right? So colon, 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 F. All right, so now we're at the F. So it keeps going, right? IELD1. Now it finds a colon. Now it stops. It takes that colon and replaces it with the null terminator, right? So think about that for a second. It takes that colon, replaces it with a null terminator, right? So 6n/0 there. It also remembers where was that first, where was the first non-delimiter character, right? So it remembers where is the F, right? It replaces that with \0. Right? So the function is destructive, right? It destroys the string that it's trying to extract the information from, right? It's going to write in a bunch of these \0s. Right? What does this mean, right? So if you try to call the function and you pass in a string literal, so you pass in something in double quotes, right? So remember what I told you, I think last lecture or the lecture before, anything that's in double quotes is technically not writable, right? So the language says if you have a string literal, right, that literal can be placed in read-only memory, which means you can't write to it. So if you pass a string literal to this function, it's going to try to write these into it, and that's probably going to cause a problem, right? So you can't parse a string literal. That's why I have to do a string copy here, right? I can't just pass in this string. because that's a literal. So I have to copy that string into another, into an array, and then I can process the array, right? You can sort of see that this function kind of sucks, right? But that's the way it works, right? Okay. Oops, where to go? Okay, so first time you call the function, right? We've got, it remembers where the f is, and it's written the \0 into the first colon, right? Now the next time you call the function, so if I want to extract the second token, we're going to pass in null, right, instead of the string, right? So when you do this, strtok continues from where it left off at the previous call. So that's interesting, right? That's kind of interesting. So now there's, so this suggests that there's some mechanism in C, right, where a function can remember something from a previous function call, right? So it's going to pick up from where it left off. So it left off by writing a \0 there, right? So now it's going to search for the first character that's not a delimiter, right? So it wrote in a \0 there, so the next character is a delimiter. So it keeps going. Now it finds the f, right? So it doesn't overwrite that delimiter there, right? It skips over it and comes to the f, right? F's not a delimiter. So it remembers, okay, that's where the start of the next token is, right? It then searches for the first character that is a delimiter. So IELD2 colon. So now it stops, and it overwrites that colon with \0, right? So it remembers where it left off, right? So it has a pointer to that f, right? Writes \0 there, right? It returns a pointer to that f, right? So you can extract that token as a string, right? Because there's a pointer there, right? And that string ends with a \0 there, right? That's why it's writing the \0s into this string, right? Right? Again, notice that the function is destructive, right? It's writing in these \0s into the string to indicate the end of the token. Right? So this little program here is just going to call strtok repeatedly until it gets back null, right? So the function will return null when it no longer finds another token, right? So to get the third token, it's going to search for the first non-null character, so that's the f, right? It's going to remember that the f is here. It's now going to search for the next delimiter, that's here. It's going to write in a \0 there and return the pointer to that f, right? Now you've got the string field 3, right? For field 4, right, it's going to do the same thing. So it's going to find the f. It's going to go to the end of the string. It's going to find the null terminator at the end of the string, so it's going to stop, right? So it's going to return a pointer to that f. If you call it again, you're going to get back null because there's nothing left in the string, right? So there's no more tokens to process, right? As soon as it sees the null terminator in the string somewhere, it knows that that's the end of parsing this string, right? So you start out by calling the function with the string and with the delimiters that you want to use, right? If the pointer that's returned is not null, right? Remember, it's going to return a pointer to this to the token, right? So first time, it's going to return a pointer to that f, right? The second time we call it, it's going to return a pointer to that f. The third time, it'll return a pointer to that f. The fourth time, it'll return a pointer to that f. If you call it again, it's going to return null, right? So while that pointer is not null, I'm just going to print out the token, right? And then I'm going to call strtok again, right? This time passing in null, right? What does it do to the string? So you can actually print out the string if you're clever. Well, not if you're not clever, right? So to print out the string, the overwritten string, right? I'm just going to loop over the string one character at a time, right? If the character is not the null terminator, I'm going to print out the character, right? If the character is the null terminator, I'm going to print out the string null. I have the length of the string from back here, right? So I actually know the length of the original string. So I can safely write a loop that processes every character in the string. And I didn't look for this before the lecture, so let me hunt down the, let me hopefully find the program. Or not. Oh, there we go. Okay, so what happened here? Right, so there are fields, fields 1, 2, 3, 4. What did it do to the string? Right, so it saw a colon. Sorry, it didn't do anything to the first colon, or the second colon, or the third colon. Right, it doesn't do anything to the non-delimiter characters. Right, the first delimiter character after the first token, though, it wrote in a null. Right, skips over the next delimiter, skips over all the non-delimiters, right, writes in null after the second token. Right, and you can see it writes in null after the third token, and then it doesn't touch the end of the string. Right, so the first time the function returns, it returns a pointer to the f, the first f in the string. Right, it wrote the null terminator into the string so that when you try to use this part of the string as a string, right, you only get back the first token. Right, so that's the trick it's playing. Right, the second time you call it, it remembers that's the location of the next non-delimiter character. Right, it's written in a null to the end of the second token, so when it passes back a pointer to that f, right, you can use that as though it were a string. Right, so the trick of writing in the null terminator into the trick of overwriting some of the delimiters with a null terminator is how this function is working. Now, how does it know where it left off from the previous step? Right? So remember, the way you call this, right, the way you process the string is you, after the first time you call strtok, you pass in null. Right? And then it somehow remembers where it left off at the previous step. Right? And so does anybody know what mechanism it's using to remember where it left off at the previous step? Right? Anybody? Anybody guess? Anybody? Anybody? You do know the answer. Well, you technically know what the answer is. Anybody? No? Okay, so way back, when we first started talking about C, right, I told you about the storage duration. Right, so remember you have automatic storage duration, right? So so a variable that has automatic storage duration lasts as long as the function lasts. Right? You now know about allocated storage duration, right? So that lasts as long as that lasts from the point where you allocate memory for it to the point where you deallocate memory for it. Right? There was another storage duration though, right? So there was static storage duration. Right? So remember, static storage duration lasts for as long as the program runs. Right? The value of a static variable in a function stays the same between calls to the function. Right? The function can change the value of the variable, right? But it remembers that value from call to call. Right? So inside strtok, there is at least one static variable that remembers where did the function end up after the previous call. Right? And so that's the mechanism that strtok is using to implement, to actually, in its implementation. Right? It's strange. It's the only standard library function I know that does something like this. Right? But it's also the only practical example of a static variable in a function that I know of. Right? Okay. Any questions about strtok? It's a weird function. Right? It's a funny function. It's hard to use, and it has certain limitations, right? Actually, does anybody see what a big limitation of this thing is? If you stare at that thing there, right? Okay, so yeah. So that's the big problem with this function, right? It can't deal with an empty field, right? So in a lot of well, especially with student information, right? It's not uncommon to see something missing from the student information, right? So believe it or not, there are students who do not have a first or last name. One of them is missing, right? So they only have one official name, right? So when you download their OnQ file, right, you get last name, comma, and then you get a comma. There's no first name, right? Then you get student number, then you get blah, 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 right? So you got a missing last name there. So this function can't deal with that, right? This function treats multiple occurrences of the delimiter as being one delimiter, right? So if you want to handle missing stuff, situations like missing fields, right, that becomes a harder problem. So we'll talk about that in the next lecture, right? So end things there, and I guess we'll meet again next week.